In this lecture, we will start with the harmonic oscillator, again with the Schrödinger wave equation and with the same potential. We will now try to solve in section 2.3.2 with the analytic method. So the analytic method, let me start here, that minus h bar square over 2m d square psi over dx square plus half m omega x square psi equals e psi. Now in this equation, I define, in order to make this equation cleaner, I define a dimensionless variable which I called psi. So this psi is defined is equal to m omega over h bar into x. Now it will be dimensionless. This is x, which is having the length dimension. If m omega over h bar is having 1 over length dimension, then it will be a dimensionless quantity. So let's check this thing. We know that E is equal to half mv square, which is also p square over 2m. And p I can write is h bar k, so it is h bar square k square and over 2m. So I can write that this small k, which is the wave number, is k square equal to 2me over h bar square, while e is h bar omega and by h bar squared. So k is equal to 2m and omega over h bar, because one h cancels and we are having like this. So from here, if I look 2 is a constant, so if I look from the dimensional point of view, then m omega over h bar is actually a wave number which is k, a momentum space. So k into x. Now k is 1 over length, means k is equal to 1 over lambda. So 1 over length into length will give us a dimensionless quantity. So we will have to utilize this number, this dimensionless quantity here, in order to convert x into psi. So I can write that from here x will be equal to h bar over m omega square root and psi. So x square will be equal to h bar over m omega and psi squared. So I can write for this one that minus h bar square over 2m d square psi over dx square. So for x square I can write d, and then this h bar over m omega will come here, and here I will write psi square. So when I write psi square here, then m omega over h bar will come here. So let's multiply this thing with m omega over h bar, then plus half m omega m omega or x squared. So I can write m omega x squared. So I will have to convert this one as well, but let me convert this at a later stage. Half m omega, and for x square I will write h bar over m omega and xi. So xi squared and psi, this is equal to E psi. Now do some simplification here, and h will cancel here with this, m will cancel here with this. So I'm having minus h bar omega over 2 d square psi over d xi square plus, now look here, plus here m omega will cancel with m omega, and we are left with h bar over 2. Let me check it here. This is omega square, so we are having this is omega square, so 1 omega will remain, and plus h bar omega over 2 here, and xi square psi equals E psi. Now if I do multiply both sides on 2 over h bar omega minus, then like I multiply both sides with minus 2 over h bar omega, then it will be E psi, and here this will cancel, so I will have d square psi over d xi square plus, so it will become minus here, and xi square psi equals minus 2e over h bar omega and psi. Now here let me define another quantity, and that I will define is, let's say, K, which is capital K, which is not a wave number, but I define it is the energy, any energy divided by the unit energy. So K is in terms of energy, which is normalized, means energy, any energy divided by the unit energy. And for the harmonic oscillator, I know that this unit energy is the ground state energy, which is half h bar omega, and I can write this is 2e over h bar omega. So K is in units of energy, which is actually a normalized energy, E divided by unit energy. So 2e over h bar omega I can write is capital K. Keep in mind that this K is the energy, while this K is a small k, which is a wave number. So these two are different things, and we will have d square psi over d xi square, and if I write for this K, this xi square will go the other side, or let me write here like this, xi square psi equals minus K and psi. So we are having this equation, which I will further write in a more simplified form, is d square psi over d xi square is equal to xi square minus k and psi. Let's say this is equation 1. So we have successfully converted the Schrödinger wave equation into xi, which is a dimensionless variable. Now we will try to solve this equation. We find an approximate solution of this equation. So an approximate solution of this equation we also call the asymptotic solution. So the asymptotic solution is basically just considering our variable at extreme limits like plus minus infinity. So I will write that if xi is too large, means like huge, going to infinity, then means on the maximum limit of this one, then this will imply that xi square minus k will go to xi square, because k will be neglected, and I will have the equation d square psi over d xi square is approximately equal to xi square psi. And now to solve this equation, let's convert it into an equation. D square d xi square is equal to xi square psi. Now the solution of this equation, we know that psi is a function of xi will be equal to a constant. It will have second order differential equation, so we will have two solutions for this. The first solution is e minus xi square over 2, while the second solution is b e to the power plus xi square over 2. Now we know about our wave function, that our wave function goes to 0 when our variable, which is xi, when xi goes to infinity. This is the general condition, and if I look to this solution, then as xi goes to infinity, this solution goes to 0. So our psi goes to 0. So this one is fine. While if I look to this equation, when xi goes to infinity, psi is not going to 0, but it blows up. So this is a trivial solution, and we will not consider this one, but only this solution. So our psi of xi is equal to a e to the power minus xi square over 2 is our right solution. So now what will be this constant, which is a constant of normalization? Let me consider this may be a complex, may not be a complex normalization constant. It may be a function of xi as well. So by keeping all the possibilities, let me write that this constant of normalization is h, and it is a function of xi. So let me write that psi of variable xi is actually h and xi in e minus xi square over 2. So now this is our solution, and we will have to go on with this solution. In a compact form, I can write it as psi h e to the power minus xi square by 2. Now how to solve this equation? So its solution is now required.